Doing problem 1D, section 7.2. Another substitution, we'll let, in this case, u be the denominator, so t to the third power plus 6, t plus 3. So du, the derivative of that, 3t squared plus 6 dt. So I have to look and see what I've got otherwise in the integral besides what I just did here. I've got a t squared plus 2 dt. Here I've got a 3t squared plus 6. Pretty close, and if I factor out that 3 there, it'll be exactly what I'm looking for. So du is equal to 3 times t squared plus 2 dt. Well, there's the t squared plus 2 dt. The 3, not there, so I'm going to get rid of it by dividing both sides by 3. So 1/3 du is equal to t squared plus 2 dt. So now when I see all of this stuff in the numerator, the t squared plus 2 and the dt, we know that that's going to turn into 1/3 du. So my new integral here is going to be the 1/3 I'll put in front. Then all of that becomes du. There's the 1/3 du. What's left? The u, the thing in the denominator. So as we remember, hopefully, the antiderivative du over u, natural log of u, absolute value. And then the last step, just replace that u back with what it was. We'll leave the absolute value on there because that term in there could potentially be negative if you have the right values of t. So just so we're clear on that, the absolute value bars really need to be there on this antiderivative unless you are 100% sure that this quantity that is within the absolute value can never be negative. Here, it can be negative. I've got odd powers of t, so it could potentially be negative for certain values of t. Anyway, there's our antiderivative.